So we're going to do problem number 57 now. And the math with problems 57 and 61 will work out much nicer than problem 54. That was kind of a nightmare. But anyway, we're going to first factor, we're going to first look at the parabola, the quadratic function, y equals x squared plus 4x. And we're going to go ahead and factor that and let y equal 0. So we're going to find the x-intercepts. And that's going to help us solve this inequality here. So the x-intercepts then would be whatever factor, whatever the factors are, set them equal to 0. So if x is a factor, which it is, we set that equal to 0. And we set the other factor, x plus 4, equal to 0. And we get x is equal to negative 4, and we get x is equal to positive, or to 0. And so having those two x-intercepts of negative 4 and 0, looking at the function itself, we know that it's going to open up, and so the graph opens up like that. And we'll get to the vertex here in a minute, but we can already solve this inequality. When is x squared plus 4x greater than or equal to 0? That would be on the interval from negative infinity all the way to negative 4, including negative 4, as well as the interval from 0 to infinity. So if we plug in any x, any real number in for x that's less than or equal to negative 4, we would see that it makes this inequality true. Any real number in place of x in between negative 4 and 0, the output would be negative, as you can see on the graph. That's why it's really nice to graph the function first before we solve the inequality, because then we could just look at the graph of the function and figure out what the solution to the inequality would be. Anyway, from the graph we can see that the domain, we already know that all of these domains are all real numbers. And in fact, here's what I'm going to do. I'm going to cheat a little bit. So for problem number 57, so for this function, y equals x squared plus 4x, I'm going to cheat a little and use my little chart. I can fill in the chart without having to rewrite all of that stuff. So the range then would be from the vertex. So let's find the vertex first. The vertex, we would use x equals negative b over 2a. And we could also know that, realize that the axis of symmetry, here let's do it this way, gain a little bit more understanding. The axis of symmetry will always be in between the x-intercepts. And if the x-intercepts are at 0, negative 4, then the axis of symmetry would be x equals negative 2. So we would also be able to fill that part out right there, x equals negative 2. So we already know that negative b over 2a is going to give us negative 2, but if we put b as as 4 and a as 1, we would still get negative 2. So there's two different ways we could get the x-coordinate of the vertex. To get the y-coordinate of the vertex, we would let x equal negative 2, and then replace x with negative 2. We get 4 minus 8, which is negative 4. So the y-coordinate of the vertex would be negative 4. So we can fill that part in right there, negative 2, negative 4. And that helps us find the range, because the range goes from the lowest y-coordinate on the graph all the way up to the highest. The lowest is negative 4, and there is no highest, so we say the range is from negative 4 to infinity. Then the intercepts, we already found that negative 4, 0, and 0, 0 were the x-intercepts, and if 0, 0 is an x-intercept, that's also the y-intercept. So we don't need to do any more work to find the y-intercept. And then we have a min value of negative 4. So the min value is negative 4. When is this function increasing? Increasing from negative 2 to infinity, and decreasing from negative infinity all the way to negative 2. Alright, I will make a new video for problem 61 as well as graphing and defining the characteristics for part C.